Hey folks, okay, I just want to talk a little bit about Lab 5. I want to go over some of the key things I've noticed in the Lab 4 submissions and maybe go over some C++ code with respect to command line arguments and file I.O. and reading things in as a line and then parsing it into individual words. So I'll go through a few bits of C++ that might help some of the things that a few folks are struggling with. Okay, so in general, again, the idea for Lab 5 is pretty much to complete the main functionality of your program. So it should actually be a fully functional elevator simulation program by the time you turn in Lab 5. So all of the I.O. checking, all of your elevator algorithm actually works. It's producing the correct output. It's doing the right error checking. I'm assuming it might be a little bit rough around the edges in places. So there might be some error checks that aren't working correctly yet. There might be some output that isn't quite working yet. There might be a few tweaks to your algorithm where once in a while it's still not getting the order exactly right. But essentially the thing should be fully functional for the end of this one. So that's the first kind of major point. You do have to make sure that everything is up to date, right? All of your feedback has been addressed. All of the problems in the man pages and in the test cases and in your batch scripts have all been corrected and updated. Your test cases are all in place. What's going to happen is I'm going to test your program on probably about 60 of my own test cases. And I'm also going to run your batch script and your UAT script on the test cases that you've provided to make sure that both your test cases are actually complete and functional and that your scripts are complete and functional. So all of that has to be in place and working. I think the biggest thing in terms of the test script revisions is that we are now going to throw in one more optional command line argument that lets the user turn kind of on and off the amount of output that's produced by the script. And again, your script should now be able to go through and carry out all this error testing. Adding the extra argument is hopefully not too huge a challenge. I did want to remind you that everything has to conform to the code standards. So your batch scripts have to conform to standards, your makefile does, your C++ code does, obviously. But do keep that in mind. For the most part, folks are doing pretty well, but there are a few cases where that's kind of slipping a bit. Remember that one of the things that the standards mention is that the error messages and warning messages are supposed to go to cerr, right, to the standard error stream, not to standard output. So you shouldn't be using cout for those kinds of things. I think those are probably the biggest key points to remind folks of. Again, what I wanted to spend a few minutes on, I tacked some sample code on to the end of the feedback for Lab 4, and I just wanted to kind of expand on that a little bit. It did look like some folks were kind of struggling with either the file I.O. side or the command line argument side, or the idea of reading a line of text in and then breaking it up into individual words so that you could see if there were, if a record had the correct number of fields in it. So I just wanted to kind of quickly run through an example that's got a little bit of all of that in it. So we've got our main routine set up to accept command line arguments. So we've got argc and argv in there so that main can collect the command line arguments that were passed. And again, argc is going to be a count of how many words the user typed in on the command line. So, the name of the executable and however many building files they provided as arguments in this case. And then argv is the one that actually has each of those arguments in it. So argv0 has the name of the executable, argv1 has the name of the first building file, argv2 has the name of the second building file, etc., etc., etc. Oh, actually, on that note, one thing I did want to mention, I noticed a few people have their C++ programs hard-coded to expect.bld files or .inp files or things along those lines. Those are only for the testing scripts. right? We use the .bld, .inp, all of that kind of thing as a framework, as a structure for our testing scripts to send data to our project to test it. Our project doesn't care what kind of a file extension it has, and our project doesn't know anything about users creating .inp files. Right? As far as the project is concerned, any file name is valid as long as the file actually exists and is readable. So any file name it gets is expected to be a building file, and it's going to read those and extract the contents from those. And all of the user requests, as far as the project is concerned, are coming through standard input. So just a quick clarification there for a couple of places where folks got confused. Again, so what I want to do is run through an example where, let's say the user passes a bunch of file names as command line arguments, and we're just going to try and store those names first off, and then we'll go through and try and open those files and read the contents. And in this example, I'm going to assume that the files are each supposed to have 3 words per line, so we can actually go through and check that and break it up into the 3 words. So here I'm going to assume that we've got some maximum number of buildings, and I'm just going to go through and grab all of the file names and store them as strings. So I'm just going to have an array of strings here. I know a lot of you are using vectors for this, that's fine. I just wanted to keep this example simple, but we've got an in this example, I'm going to say, okay, I can support up to 32 buildings as file names. So we'll create an array to hold the file names. We'll keep track of how many we've stored, and 0 initially. I'll check to make sure that they provided at least 1. So if argc is 1, then they didn't provide any command line arguments. That's not right. So I'm going to give them an error message and bail out. Tell them you're supposed to run it with at least 1 file name, something like that. Then I'm just going to go through each of the remaining arguments, so from 1 to argc minus 1, and I'm just going to store each of them in the array. So I'm just going to copy argvb into the next spot in my array of strings. Right? Again, so just to go through and grab each of the file names that they provided. And then I'm going to go through and say, okay, well, for each of those file names, I'm going to try and read that file and see if the contents are correct. Obviously you're going to be doing something more sophisticated than that, but this should get folks started enough to get over the file I/O hump. So I'm just going to go through, and I'm going to have a routine to go through and you pass it a file name, and it's going to try and read that file and see if the file is okay. So I'll call it read building. I'll pass it the current file name, and I'm just going through each of them. And if it returns true, everything worked. If it didn't, something went wrong. Right? So I'm just going to try and read each of those. So in that read function, again, we're taking the file name as a string. We're going to open it up. So easiest way to do that is just to create an ifstream object. I'm going to call it infile. Initialize it from the file name, and then we'll check and see if it's open or not. If it didn't open, then something went wrong, right? The file didn't exist, it wasn't readable, something like that. So if the file is not open, give them an error message and bail out, return false. Otherwise, it did open correctly, so we can go ahead, try and read the contents. So in here, I'm just going to try and process all of those lines, and then eventually close the file and return true. Right? So all the mechanics in here, what I'm going to do is read it 1 line at a time until I hit the end of the file. So I'm going to have a string for my line. I'm going to have my do, while not end of file. And at each step, I'm going to try and read 1 line. So that's what I'm going to use the getline for, read 1 line from the file. Make sure that that didn't trigger my end of file. So if that read succeeded, I'm not at the end of the file. Then I'm going to try and break that line up into 3 words. And if the line doesn't have 3 words on it, I'll spit out an error message. All right, so in this case, I'm creating 3 strings as the 3 words I'm going to try and read. And the way we can do this is we'll create a string stream. So from the string that's got the line in it, we're going to create a readable stream. So this istringstream So strm is going to be the name of the stream that we create. So that's just a variable. The strm is just a variable name I made up. So I'm going to create one of these string streams, and I'm going to create it from that line that I just read in. So now I can read from this stream the same way I would from cin or from infile or anything like that. So for my stream, I'm going to try and read 3 words. And if that succeeds, great, the line had 3 words on it. If it fails, it didn't. So I'm going to check, and if it failed, then the line didn't have 3 words on it. And if it succeeded, I'll just print out what those 3 words are. And again, you'd have more interesting processing going on. But this is a basic idea of how we can take, read it a line at a time, and then see if that line's got the right structure, the structure that we were expecting. And it's just going to go through and do this line by line until we hit the end of this beast. So we'll try and compile here and make sure that that worked. That did work. And we'll try executing it. Oops, I suppose I should show you what my file contents were here. So I've got this one file that's got a bunch of lines with 3 words on it, and one line that's missing some words, and then some more. So we want to see, so, oops, blah, 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 where's the command I wanted to run? So let's run, well actually, let's run the program once without any arguments, just to make sure that it actually warns us that we're supposed to use it correctly, right? So it's telling me, argc wasn't big enough, you didn't provide enough arguments. So then I'll try it with just some made-up file name that doesn't exist, and it should tell me that that file couldn't be read. And then maybe I'll try it with that file one. And so for this one, most of the lines should be okay, but it should tell me that one line is wrong. Right, so it goes through, opens up the file, gets the 3 word from the first line, the 3 words from the second line, the 3 words from the third line, finds out that 4th line only has 1 word on it, goes on and tackles the next line, again 3 words. So again, it can keep going through and just identifying anything that doesn't have enough content on it, which of course is going to be useful when you're reading your building files. Or for that matter, you can use something similar when you're reading the user input, right? Get a line of user input and then break it up into the however many words you're expecting for a user request. Right? So this kind of a structure can work out well. And again, we can throw in a bunch of extra non-existent files, and it should tell me that those didn't open. Or of course we can throw in file 1 again, and it should try and read it again. Right? So we can go through and give it as many files as we want, and it'll process them all. So hopefully those couple of chunks from our sample here in terms of how to get our command line arguments, how to check them, how to go through and read a file, right? How to open it effectively, check if it opened, read it line by line, and break it up into pieces. Hopefully that will help folks who are struggling with pieces of the assignment itself. All right, I will leave it there for now. Feel free to catch me on Discord or fire me an email, or we can set up a Zoom meeting, and I will see you, well, I guess this week in the Zoom sessions for the lecture in the lab, and next week we should be back in person. So hopefully. All right, I will leave it there.